saw earlier. Also of note, this does deplete normal NK cells in the way that we've done it so far. But we have hopes that since they're cells of the innate immunity, they may be more able to return. And if these cells take a lifetime to accumulate, we hope that as the NK cells will come back and the senescent cells or what have you won't come back very effectively. And furthermore, we have some pretty good ideas on how to just get around this problem entirely that I'm really not going to get into at this moment. But the total cost of everything we've done so far was about $30,000 in the last year. So what are we doing next? Obviously, we need to repeat this over a longer period of time. This was essentially, we just got these cells out of the blood compartment of the mouse. These T cells are in numerous body compartments. They migrate between like lymphatic fluid, sequestered in the lymph nodes, etc. So we need to do this over an extended period of time in order to get a significant percentage of these total senescent cells, or whatever you'd like to call them. After that, the obvious next step is to test vaccine response or some other immune challenge in these mice versus mice that haven't had the treatment. And we should finally be able to test directly if all this, immunosenescence, at least according to these markers, really is relevant the way that we tend to think it has been. And of course, dreaming of higher animal studies and clinical trials. One thing that I would like to note is that our device is plug and play, and so if someone can think of better markers for us to go after, we can certainly do that very easily now that we have the device constructed. This is the team. Mentioned Keith, John, Tim, Brian, and Mark. I'd also like to give a special thanks to SENS' own Ben Seeley, who was the one who really got us started on using these analytic tools in a therapeutic manner. Thanks.